The distance formula. So this chapter we've been working with our powers and our roots, and we've been talking about the Pythagorean theorem, which deals with right triangles and the hypotenuse, so the two legs that are attached to the right angle and the hypotenuse, and being able to find any of those missing distances. So the distance formula is a reworking of the Pythagorean theorem. So what we've done is we've kind of taken the Pythagorean theorem and we've changed things around so that we are able to kind of figure out the hypotenuse without going through all the algebra. We've kind of done it all in one step. So it kind of looks really complicated. It looks very funky. It's pretty much the Pythagorean theorem though. So we're going to walk through how that works, and then we're going to walk through an alternative way to look at real world problems and trying to find for that hypotenuse without using the distance formula. So we'll look at a few different ways. So the distance formula is the distance d between any 2 points. So we're talking about the coordinate plane here, x1 and y1, and x2, y2. So we've seen this before here when we worked with our slope formula, x1, y1, x2, y2. It's given by the formula d equals, so d is the distance, the square root of x2 minus x1, and then we're going to square that distance, square that difference, plus y2 minus y1, and then we're going to square that difference. Okay, so you'll notice what we've got here. We've got some squaring, we've got some rooting, a lot of the things that we work on when we deal with the Pythagorean theorem. So let's apply this and see how that plays out. So find the distance between 1, 5 and -4, -2. So what I can do is I'm going to think about each of my points as x1, y1, and x2, y2. Again, this looks just like it did with our slope formula. So I suggest you write it out this way. x1, y1, this is what my numbers are going to be. x2, y2, this is what my numbers will be. FSSU. So I'm going to start with my formula here, which is kind of long and drawn out. You will not have to memorize it on a quiz or a test. We will give it to you. It's on your MCAS reference sheet also. Now I'm going to substitute in here. So x2, my x2 is -4, my x1 is 1, my y2 is -2, and my y1 is 5. So I'm just substituting in there. Notice the parentheses around the subtraction, and we're squaring whatever is inside the parentheses. Okay, so hang on to those parentheses until you square. So now I've got d equals, and now I'm going to do my subtraction here. I have to work with my negatives. -4 minus 1 is -5. -2 minus 5, -2 minus 5 is -7. So notice it's -5 squared plus -7 squared. Be careful with your calculator here. I would highly suggest that you just do this mental math. These are small numbers, you should be able to deal with them. But a negative times a negative is a positive. So whenever you square something, you always get a positive. You're not going to get a negative here, even if it's a negative in the parentheses. So -5 times itself is +25. -7 times itself is +49. I should have two positives here. I'm going to add those together and get 74. And then I'm going to find the square root of 74, so I get approximately 8.6. Since I didn't give you distances here, we're just talking units on a coordinate plane. So FSS, the units don't really particularly apply here. We could put units if we wanted to. So 8.6. So this is how our distance formula works between 2 points. Again, we're finding the distance between the x's. We're finding the distance between the y's. We're squaring that, and then we're finding the square root. So we're basically finding this distance here. We're finding this distance here, which you'll notice this is x. This is A and B, my two legs. I should have a right angle drawn in this corner here. Let's put one in there. That's a right angle there. And then we're squaring those, we're adding them together, and then we're finding the square root, which is all we're really doing. It's just the Pythagorean theorem. All right, let's look at a real-world example of this and see when we might use it. So a player kicks a soccer ball from a position that is 10 yards from a sideline and 5 yards from a goal line. So it's 10 yards from the sideline, 5 yards from the goal line. So I could draw this out like it's on a coordinate plane, do my sideline, do my goal line. It's 10 from the sideline, 5 from the goal line. A ball lands at a position that is 45 yards from the same goal line, 45, and 40 yards from the same sideline, so 40 from the sideline. How far was the ball kicked? So we're looking for this distance right here, how far that ball was kicked, so from here to here. So if you look at it, you'll see that we could create a right triangle out of that. We're going to use a distance formula first and just plug those 2 points in there. So again, you want to think about which one you're talking about as x1, y1, and which you're thinking about as x2, y2. Plug them in. I have 40 minus 10 squared plus 45 minus 5 squared. I get 30 squared plus 40 squared. 30 squared is 900. Remember, I'm always going to get a positive there when I square that. 40 squared is 1600. Now I'm going to do order of operations. I'm going to add what's inside. 900 plus 1600 is 2500. And the square root of 2500 is 50. So it's 50 yards from here to here. And we've talked about thinking about, does that number actually make sense? Well, if this is 30 yards and this is 40 yards, well, it makes sense that it's going to be shorter. It's going to be longer than either one of those, but it's going to be shorter than if it went all the way around. So 50 yards makes sense. Now, if you're looking at a graph like this, or you're looking at a real-world situation, and the distance formula just, there's way too much going on there for you, you can always draw yourself a right triangle directly on the graph. So notice here what I've done is I've drawn a right triangle. If I was just using the distance formula, I don't need that. I could just go straight from the ordered pairs. But I can draw a right triangle and then work from there. So here I've got draw a right triangle. So I'm going to draw a right triangle. Here's my Pythagorean theorem. A squared plus b squared. There's dust on there. That's what's weird. A squared plus b squared equals c squared. So my distance here from 10 to 40, that's a distance of 30. So one of my legs. My other leg is a distance from, what are we going from, 5 to 45. So that's 40. So my other leg is 40. So I'm going to do 30 squared, which is 900. I'm going to do 40 squared, which is 1600. 900 plus 600 is 2500. So 2500 equals c squared. This should look very familiar to you. And then we're going to square root both sides. So we get the square root of c squared is c, and the square root of 2500 is 50. So we get 50 yards. So I have the same answer, and you'll notice that a lot of the numbers are very similar, because really this is just a contortion of our Pythagorean theorem. So you can just use the ordered pairs straight up the way they are. Just plug them in and then solve. Or if you're looking at a coordinate plane, you can absolutely draw the right triangle there and figure out the distances. So this goes from 5 to 45, so this is a distance of 40. This goes from 10 to 30, so this is a distance of 30. And I can do 30 squared plus 40 squared equals c squared and work from there. So two different ways to work around this. Here's how your distance formula works. And then another way is by actually drawing the right triangle. So some real-world problems involving the distance formula.